All right. Thanks so much for having me, folks. I really appreciate it. I'm going to be talking about Dark, which is a new startup that we're launching in about 8 days from now. Yeah, we've been working on it about 2 years now, so we're excited to get it out into the world. And so this is a little preview. Things may go wrong. I've practiced it only 20-30 times, so things are not going to go perfectly. Before I start, though, I want to talk a little bit about me, the journey here, the suggested topics of for this talk were the journey from CircleCI to Dark. So I'll touch on that, and then I'll get into Dark. So I'm Irish. I did my undergrad in Trinity College Dublin, and then I started a startup with 5 friends, and that was a bad idea. That was too many friends to start a startup with. So I dropped out of that after about 4 months, and then I did a PhD in static analysis and optimization of dynamic programming languages mostly. And that was really interesting because since then I've basically turned my career into convincing investors to give me millions of dollars to do fun compiler projects. And this is the second one of them. But CircleCI was the first one. I started that in about 2011. We started, and about 3 months after we started, we had a minimal viable product and we had customers. And over the next month or two, we got 20-ish customers, and then started trying to charge them. I didn't realize it at the time, but you didn't actually need a payment page. You could charge them in the Stripe dashboard, and if I'd known that, we would have had paying customers a couple of months earlier. But it took about 3 months to get to paying customers, and we had to do some technology changes to make CircleCI fast. But so 3 months to first customers and 3 months to first paying customers, and after that we stayed in private alpha for 3 or 4 months, during which time I was desperately worried about our growth rate was not high enough. Why weren't we growing? And sort of eventually I realized, well, we're in private alpha and there's no way to sign up, and that's probably the number one problem. So we fixed that, and then we basically just spent the next 2 years just constantly and frantically building out the product. It was originally something that worked for Ruby, and over a couple of months it became something that worked for 50 different versions of Ruby, and then Python, and then 50 different versions of Python. And it was a different time back then when it was before all this Docker and this microservice stuff, where it was a much easier time to build the sort of product that Circle built, which of course meant that that when all that microservice and Docker stuff happened, we had to completely retool our platform, which we did shortly after I left. So I continued being CEO for the first 3.5 years. Got us to about 25 people, a couple $1 million revenue, and then I decided I didn't like being CEO. That was not a fun job, and handed it off to other people, and then eventually left myself to sort of figure out what I wanted to do with my life. And so what I wanted to do with my life is Dark, where you'll notice I'm CTO, not CEO, because that's a much better job, especially when you're paired with an extremely competent CEO. So Dark is a programming language. It's also infrastructure. It's also an editor. And it's sort of complicated how that all goes together. So I'm going to start sort of at the start a little bit and explain how we got here. So I'm going to stand to the side here. When I started programming, I started programming in Unix. Have people written Unix programs? Is everyone familiar with this configure and make? Okay, I see a lot of nodding. So configure and make is how we installed software in the old days, long before there was SaaS. And when I started writing Unix, we had to not only use this configure and make file, but we had to write these scripts ourselves. So make files were a simple sort of declaration of dependencies and how those led to software being compiled, or to individual files being compiled. And then there was configure, and configure was a sort of a polyfill, if you will, over all the various different Unixes, the Linuxes, the BSDs, and Solaris, and all the other Unixes of the day. But then those weren't actually enough to build software, because we were writing thousands of lines of shell script for configure files. Make files were hard to maintain, so someone made autoconf. And autoconf is a tool for generating configure files. And then they made automake, which was a tool for generating make files. And what was interesting about this, this eventually became a suite called AutoTools, and it had autoconf and automake and makefile, and another tool called libtool, which was a sort of a polyfill for dynamic libraries on various Unixes. And what happened, or the way that this arrived, was incrementally. Right? We made very, very small changes. It started with just make in the 70s, and people built up configure, and they built up even a library of autoconf scripts called the autoconf macro archive, and just more and more and more stuff until it became extremely mature, became used in thousands and thousands of projects, and was in the end a completely nightmarish hell of complexity. So everybody hated this stuff by the time it was done. There's nobody still today who loves AutoTools. It's 6 different languages. In autoconf, use a language called M4 that nobody knows to generate this other language, shell, which everyone thinks they know, but no one actually knows. And it just sort of got there through the gradual improvement. Every step that got done was an incremental improvement over the thing that came before. But at the end, it got to the point where people have written like 6 or 12 different replacements for AutoTools as build systems, because it's so nightmarish. And we kind of do this a lot in our industry. So you might be familiar with Docker. And Docker started out really nice. It was this lightweight virtualization. It was this nice, easy way of having dev production parity, of packaging up containers to ship them into production, of sharing your developer tools with your team. And then came Compose and Swarm and these tools for doing more complex things, and that was pretty cool. And then there came Kubernetes. And Kubernetes was great. We're doing things like Google now. We're orchestrating fleets of microservices, and we're doing DevOps. And then Kubernetes wasn't enough. So then they added service meshes, and they added API gateways and container registries and service discovery. And this is what the Kubernetes landscape looks like today. There's 455 tools in this slide. 455. And the thing is, it's impossible to know what all of this stuff does. At the top, it says, you can't quite see it here, but it says overwhelmed, and it gives you a link to the lesser slide for this cut down slide. Yes, I am overwhelmed, in fact. How could we not be overwhelmed? Why the fuck are they doing this? And I say they, but actually it's we. Why do we do this? Because as an industry, this is what we do. We build things, and things accrue and accrue, and no one ever takes things away. So if you look at AWS, there's 200 services on AWS and more being added all the time, and they're never taken away. The last good thing in our industry was garbage collection. Garbage collection was a tool which took something away. We used to spend 40% of our time doing manual memory allocation back when we were writing C and C++. And garbage collection actually removed that and bought us this 40% of our time back. And there's an essay that talks about this, and it's called No Silver Bullet. It's by a guy called Fred Brooks, who also wrote The Mythical Man Month. And in it, he talks about essential complexity and accidental complexity. And essential complexity is the stuff that you actually need. It's your product's differentiators, it's the value that you bring to your customers. An accidental complexity is the stuff that you need in order to do that. It's the stuff that actually doesn't bring value to your customers, but you're still required to do it anyway. And the title is No Silver Bullet, and his point is that you can't have a 10x improvement in developer productivity, because in order to have a 10x improvement, you have to remove 90% of the stuff by definition. And so 90% of the stuff would have to be accidental complexity. And in 1986, when he wrote this, 90% of the stuff was not accidental complexity. Today, though, we have this. And more complexity across the entire ecosystem. And there's just accidental complexity anywhere. So to build a backend today, the amount of stuff that you need to know, even without looking in the cloud native ecosystem, the Kubernetes stuff, you need to know Docker and Git and load balancers and dozens of AWS services. You need to know SQL, you need to know NoSQL, you need to know Kafka and Unix and gRPC and Thrift, GraphQL. You need to know security and optimization and monitoring and observability. And it just keeps going and it keeps going, and it's exhausting. And all of this, to me, is accidental complexity. And the kind of accidental complexity that we have in our industry, there's three broad categories that we're dealing with Dark. There's infrastructure complexity, there's deployment complexity, and there's API complexity. And infrastructure complexity, we've seen. And the essential complexity of infrastructure is actually really simple. You need a service in the cloud that receives data, that processes data, that stores and queries data, and that sends data. And what you don't need is AWS. You don't need 200 services. You don't need containers. You don't need Docker. You don't need Kubernetes. You don't need service meshes. None of that stuff actually matters. What the essential complexity of writing cloud software and writing backends is just receive data, process data, store and query data, and to send data. And it's similar on the deployment side of things. This is a typical CI/CD pipeline, and people are often surprised that we're talking about removing the deployment complexity, because deployment complexity feels like something which is essential. You have to get your software from your machine to the cloud, and you have to make it safe along the way. And all this stuff got built into it because we need to make that safe. But when you look at this process, which part of this actually brings value to customers? Which part of this is a thing that customers actually care about? And almost none of it. You could make a case for a couple of the 34 steps in here that customers actually care about them, but the vast majority of them that you don't. And it's kind of ridiculous to think about how we got here, because we used to deploy software by shipping the software to production. And that was the thing that enabled it for users. But then we've changed that. Today we use feature flags to enable features for users. And so there's a separate mechanism to do that enabling. And so what does the first step do? What does the act of shipping it to production do? All that's left once you remove enabling it for users is risk. It's a thing that can take your system down. It's a thing that can cause you to get paged. So API complexity is the third. And APIs are really, really hard. It used to be that APIs were super easy. They were functions that you imported into your code base, and then you would just call them. But now functions are at the other end of a remote procedure call. They're part of a complex distributed system, and dealing with them means that you have errors, you have to deal with retries and backoffs, rate limiting and auth and serialization, and there's all these different formats like GraphQL and REST and gRPC and Thrift and SOAP and all that. And that too has just become mired in complexity. And Dark is about removing that complexity. The sole purpose of Dark is designing how can we make backend software that does not have all of this accidental complexity. And it's kind of been a struggle to describe Dark to people in the past when they've asked what Dark is, because I kind of think of Dark not so much as what it is, but as the absence of accidental complexity, as the thing that we are trying to remove to the world or from how we write software. And the product that we created is an accident of the problem that we're trying to solve, and not so much the thing that we were trying to create. So Dark is moving in 2 weeks from private alpha to private beta. And what that means is that we're confident in a couple of our solutions to a couple of these problems. So we feel that we have a really good solution to infrastructure complexity and deployment complexity. And that means that we're confident to let a lot more people in. And it also means that Dark is still in private beta, so it's still not completely ready. We took a lean approach. There's a lot of shortcuts, a lot of hacks, a lot of compromises to get us there. But we feel confident that we're on the right path to solving these. So I'm going to give you a quick demo of Dark, and Ellen usually gives the demo, so we'll see how this goes. Sorry for the delay. I'm going to have to mirror this or I can't see anything. Or I could just turn this around. There we go. Okay. Am I still good on the? All right. Okay, so Dark is a way of writing backends. So I'm going to write the simplest API endpoint we can think of. It's going to be hello world. And that's not what that did. So I'm creating a new HTTP handler called hello world. It's a get, and I'm going to type hello world. And now I'm going to open this up in a new tab. And this is me accessing via my browser a hello world route that we just created live on the internet. This is, you can check this out in your phones or whatever. And that's what deployment is reduced to now. This is how we write software using Dark. So we can do some more complicated things to it. So I'm going to change this so that it takes a user parameter, and then I'm going to change this to be hello user, and then I'm going to go back to that. Where did it go? And then I'm going to change this to hello Paul. There we go. Hello Paul. And so it's a programming language. It's a full programming language. It's not no code or low code. It allows you to do basically anything. And so what I'm going to step you through, we'll just get rid of this. What I'm going to step you through is building a backend to a front-end app. So we have a front-end app available. Where is it here? That's not appearing on that screen. Okay. All right, well, apparently I can't copy my console over to your for you to see, but this is a simple React app, and I deployed it slightly earlier to this Dark application, and what it looks like, I'm going to create. There we go. I'm going to create a way of loading that. So at the /route, whenever you do a get, which is what your browser does naturally when it goes to a domain. We are going to serve a static asset called index.html. And I'm going to open this up. And so this is a simple Rails app, or sorry, a simple React app that we built earlier. And before you all came in, I deployed it to this canvas, and it's supposed to be a clone of the Envoy, the sign-in app. When you come to a startup and you fill in your name, we intended to change this name. Apologies to Envoy. I forgot to recompile it. So it's got a right. I forgot to recompile it, and so it is pointing to a different thing. So give me 1 second. So I'm going to point it to this thing, and then I'm going to recompile it. And then I'm going to redeploy it. Build, and then Dark. Okay. So that's redeploying. So in a moment, we're going to see a new. All right. So our second set of assets has been deployed, and since this says serve latest, it's presumably going to serve the latest one. And there we go. And it doesn't say Envoy anymore. Okay. So this I made it point to this application that we're using, and it 404s. And it 404s because there's no routes for it. We haven't created any of the routes that this application needs. And the typical way that you would deal with this is that you would look into your inspector to see what is the thing that's going wrong. Well, I see that there's a 404 from /hosts. But in Dark, we actually can deal with this slightly differently. We've got a 404. We've got a set of 404s available here, and so I can see that there was a request made to /hosts, and I click this, and now I can see the actual trace of the request that was made. So this was the actual request, and I can see its headers, and I can see its cookies, of which there are none, its body, which is all null, or all empty. And I'm going to return what this requires, which is a list of users. And then if I refresh this app again, that 404 succeeds, and we can see that there's those users. And this is how quickly you can turn things around. We call this the Dark flow. It's where you're sort of co-building the two things together and sharing data from one to the other via these sort of like live values and live requests. So this is a bit of a hack. So let's put this into a database. So I need a host database. So I'll make a new DB there, and that's going to have a name, which is a string, and a phone number, because we're going to be notifying people of their arrival, and it's going to have a Slack ID, which is all string. Okay, so we have now a host database, so we're going to have to put something in it. So let me quickly create a tool to do that. We call them REPLs. They're not really REPLs, but they're just sort of like the tools. And do you guys need me to increase the zoom level? Yeah, okay. Okay. So here, I'm going to create something to add something to a database. So I'm going to do a db set of a user to a database. So I'm going to, the value that I'm going to set here is, so it has a name, which is Paul, and has a phone number. So this is just going to be exactly the same as we made above. And this is my phone number. Please don't call me. And then Slack ID, and I prepared this one earlier. We have, that was something I tucked into the canvas before we started. And now, in order to put something into a data store, we need a key for this. I'm going to use my phone number because that is how we're doing this. So I'm going to extract this variable into a let, and I'm going to call that phone number. And then I'm going to use that as the key as well. Phone number. And then the table is what? Hosts. And so I'm going to execute this by pressing this green button, and that executes right in our thing. We don't need some sort of shell or terminal or anything like that. And we can see here that the database immediately locked. And so once a database has data in it, it immediately locks. And the reason for that is you can't just change the schema or what will happen to the data. And you can see the start of this continuous delivery thing that Dark does, always making sure that whatever changes you make to your program are safe, and that you can't take down or you can't stop the stuff that already works from working without doing so very deliberately. So all right, we've got users in here. So now let's change this to be users, and I'm going to do a query, and I'm going to query. No, what am I doing? I'm getting the list of users. I'm going to go through the users. I'm going to get all the users, and from the host table, and then I'm going to go through them and just get their names, because that's what we need. And you might recognize some functional programming here if you're familiar with it. All right, so let me click that and see what happened. That looks right. And now we just have a list of users. That looks right. And so I'm pretty certain that this is going to work because I've checked in my editor that this was going to work. And we can see here is Paul. OK, great. So now there's a visitor. So let's put the visitor's name in. And we can see that it failed again because there's another route that we've yet to fill in. So we're going to do the same thing, and we're going to where did that 404s go? I'm going to have to change the zoom a little bit here to get that back. And so we see that there's a post to visit. Let's get that. And change zoom. So what do we do when we have a visit? Well, we need to save it in the database. So let's do that first. So we're going to do a db set into of the value, and I can see the actual value that came in is request.body, and let's see what that looks like. OK, that's our request.value. That's the shape we're expecting. So we don't need to go back to our code, go back to our browser to figure out what is the shape of this. We can see it right in our editor, and I need a key, so I'm just going to generate one because there's no real information about the right thing here. And then I need a table for this. So let me create a new table. So this is going to be visits. I'll create a new DB. And visits, as we just saw, it has a host, which is a string, and a visitor, which is a string. And this is really all it takes to create a database, as you saw a moment ago. So let me add this here. Visits. And I'm first going to generate a key. OK, that's what a key looks like. And now we're going to save the user. And so this request that started a few minutes ago when I actually made the thing, we're actually building up that request using that request data. So we don't need to go back and redo it. We've got all the data here that we're working with, and we can actually play it and execute it as we come along. So far we've received a list of hosts, we've received a visitor, and we've saved it in the database. And that's not particularly useful because no one is checking their database to see if anyone is visiting them. So we're going to have to send a text message and send a Slack DM to do that. So let's see what that looks like. So I'm going to insert something above because our editor is a bit weak, but our new version of our editor won't need that. So I'm going to emit an event to a background worker, which is going to send a text. So the event is going to be request.body, and the no, I'm actually going to need the key. So let me extract this instead. Extract variable. I'm going to call that key. You can see it fixes that up as we do that thing. So I'm going to put this into database. So I'm going to emit this too, and I'm going to call this send text is what this the worker that we're going to send to. And again, I'm just going to press play here, and then we can see that there's going to be a 404 to worker send text, and it's not technically a 404, but that's what we're calling it at the moment. While I'm here, I'll just hide that. And then we can see again the same thing. There was a request made or sent to this worker, and we can see the value that was sent to that. So we're going to do something quickly with that. We're going to just send a text, Twilio send text. So this is a library that we've wrapped for sending texts. And I have saved some of these things as variables in advance. I think that's the token, and then Twilio number to number is going to be, all right, I'm going to have to get the thing from the database. So insert that above, let number equals, actually I'm going to have to insert that above. That was what I intended to do. Do a quick undo here. Insert that above. And what I'm looking for is the visit, which I'm going to get from the database. Get one, db get many, get db get. And the key is event, and the table is visits. There we go. OK, so I can see I got the data, so that code works. So the number is, oh, I still need to get the host. So let's start with that. Let the host be db gets. I'm querying from the DB, and I'm looking for someone whose name is the visit dot. And I can see the autocomplete, even though there's nothing, I've never specified anything about types. The fact that this data is here means I can extract it. And then I'm looking for that in the hosts database. So let's see if that worked. That did in fact work. So I can find my phone number and Slack ID. So all right, let's send this to host.phone number. Again, we're using the data to do autocomplete. And the body is someone is here to see me. Who is here to see me? Host dot. Nope, I'm the host. That's not who's visiting. It's the visitor who's here to see me. Visits dot visitor. Is here to see you. All right, and let's see if that works. So it does. Twilio seems to think that it has worked. Let's see. And it says visitor is here to see me. I'm not actually sure how to show you on my screen, but there we go. Visitor is here to see me. So that's all it takes to write a program in Dark. And I was going to show you the same thing for Slack, but it takes another 5 minutes, and it doesn't really show us anything more. So we're going to go back to our regularly scheduled programming. And there we go. OK. So that's Dark. So Dark is a holistic programming language, editor, and infrastructure. And what I mean by that is all of those come together in the same package, and in particular, everything that's interesting about Dark and everything that Dark does to remove accidental complexity comes from the fact that we have combined these. You write code in the Dark editor. You deploy instantly to the Dark infrastructure. And the code, as you've seen, and this is some code that you might be familiar with if you did any coding interviews in around 2009. But the coding is relatively straightforward. It looks like a regular language. You're just writing regular code. It's a bit more declarative than many languages because of its functional influence. But it's just kind of regular code. And we can see, and as we just saw in the demo, we're making requests. we're querying some data, we're saving some data. So those things that I said about how the essential complexity of backends is receiving data, storing it, processing, and sending it. That's exactly what we've tried to limit our product to. So the core principle that we use to design Dark is don't invent anything new. And what I mean by that is that our language, our infrastructure, and our editor are all based on existing concepts that are tried and tested. It's just code. Our infrastructure is based on the same sort of things that people write their infrastructure in today, the same concepts that people use when they're writing software in things like Rails, but we're just trying to remove all of the accidental complexity from those things individually. So if we look at the language, all these concepts are things that exist in many languages. It's a functional imperative hybrid. So what I mean by that is we take a lot of ideas from functional programming, but we put it in a mostly imperative shell because we're not really dogmatic about the functional stuff. It takes influences from languages like Rust, OCaml, Elm, Clojure, Swift, TypeScript, and Rails. Those are probably our 7 greatest influences. OCaml is probably our largest influence with a lot of Elm and Rust and Clojure. Well, okay, there's a lot of influences. And the reason that we choose this set of sort of functional languages stuff is that we believe that it makes it really easy to reason about programs. When we look at the problems of how difficult it is to understand what your program does today, we tried to pick a set of features that really allow for good reasoning. So immutable values, things like using records and enums instead of object orientation and inheritance and that kind of thing. We use options and results instead of nulls and exceptions. So there's no exceptions in our language and no null. And we use tooling to sort of make up for that. Static types, garbage collected, and of course because we're not fully dogmatic, there's imperative statements. And you saw a lot of the code that we wrote was fairly easy to understand, so sort of looking top to bottom. This is our editor. So our editor is a structured editor. And what we mean by structured editor is that it's not just text. You're not just typing text. Whenever you type something in Dark, it's not possible to have a syntax error. There's just no syntax errors, not possible at all. And the way that we did this is that instead of writing text, what you're writing is every keystroke you make changes the AST. The AST is sort of the in-memory representation of the program. Think of it as equivalent to a DOM for HTML. So Dark has no parser. You're just changing it, and no parser means no parse errors. So the editor that I was just showing you was our 2nd generation editor. This is our 3rd generation editor, and it's been designed to feel incredibly textual and feels just like you're typing text, except that you're actually not, and so it's not possible to end up in this sort of thing. So let's. Yeah. So here we're just typing characters, and at the end we're just going to backspace over the whole lot of things, and we just kind of build it up from. We build like expressions and that kind of thing up from understanding the context that we have, and then to get rid of it, just backspace it all. So it just feels like an incredibly textual experience. And we're basing all of this again on known stuff that's been out there for a while. Our main influence was a thing called paredit, which is what you use one way of writing Lisp in Emacs. We've also been influenced by things like Sketch and Hazel, which are research projects, academic research projects. MPS, which is the thing that's behind IntelliJ, and it's also similar to some things like Embedder and Tofu.js and some other experiments like that. So our infrastructure also incredibly just the same as what's been done before. Again, nothing new to invent here. So we have familiar concepts. There's data stores. There's scheduled jobs, which we call cron jobs. There's workers, and there's HTTP endpoints. So standard things that you're familiar with. No one will be surprised by any of these. No one will wonder what they are. And then we have REPLs, which are just for making in-editor tools. So if we're not doing anything new with the language, where is all the innovation coming from? Well, a saying that we have is innovate at the boundaries. And what we mean there is the boundaries between the editor, the language, and the infrastructure. So most of our industry works on making incremental changes to existing things. So programming languages exist, so I'm going to make a new programming language. Infrastructure tools exist, I'm going to make another infrastructure tool. Editors exist, I'm going to make another editor. And the intersection between the two, between editor and language and language and infra, and infra and language are not particularly well explored. And in particular, the intersection of all three, which is the stuff that makes Dark really interesting, of infrastructure, language, and editor, there's been almost no exploration. So there's been a bunch of stuff on editor and language. In particular, you can see stuff paying off these days, like language server protocol. We after 50, 60 years of programming, we finally have a reliable go-to definition in our editor. You can see work by people like Brett Victor and Lighttable and Eve, which are sort of the state-of-the-art cool stuff. And that happens because they're exploring the line between editor and language. And apart from that, there's very little work that people have done, which means that there's an incredibly large amount of low-hanging fruit. So when we combined these three things, a lot of the stuff that we did that blows people's minds and that was really interesting in our demo and of the stuff I'm going to show you, it was just the most obvious thing. Anyone in that position would have said, oh yeah, it would be really useful here if we could see actual requests that came in, or it would be really useful here if I could see the value of the code that I'm editing at this moment. And implementing it wasn't even that hard. It was just a case of sort of like being first to combine all these three things. So the first and probably the biggest of the three things we have is called deployless. And deployless isn't a term that we coined. It's one we're vaguely sheepish about. And it's just like it's very similar to serverless, of course. And it was coined by Jess Frizzelli. And in deployless, there is a deploy, just like in serverless there are servers. But just like in serverless, you don't have to think about the servers. In deployless, you don't have to think about the deploys. So what it means to be serverless, we're gonna define it a little bit. An instant deployment, but not just an instant deployment. That there's actually no deployment step. So if you've got a save and it's instant, that's kind of not the same thing. It's more that as soon as you write something, it is already deployed without having to take a separate step, and definitely not a separate long process to get that code into production. And then the third, and I think that this is the most important thing, is that it's safe to make changes. So in the old days, we used to write PHP in Vim on a shared server, and we would edit the program live as our users were trying to use it, and that didn't always end well. I remember doing deploys where where HTTP requests would start in one deploy and end in the next deploy because PHP wasn't designed for that. That was just how they did the deployment. And so we don't want to go back to that bad old world, but we do actually have fairly fond memories of having that really quick response time and quick ability to turn things around when we wrote software like this. So we want to take that experience, but make it very safe. And so safety is a thing that Dark is really designed around, and how that deployless works. So this is a screenshot of the main tool that we use for this, which is feature flags. A feature flag is a glorified if statement. You may refer to it as a feature toggle. It's vaguely similar to A/B testing, quite similar to blue-green deploys. And it's just an if statement that we put in our code where we decide which users see this particular feature. So what we're showing you here is that there's this structure here, which has a name and a timestamp, and we cover it in a feature flag by using an editor command, and then this is the UI for that. This is the old version of the code, and here we're going to write the new version of the code. And what we have here is essentially a sandbox, because no one is seeing this code that we're typing. This code is being used by users, but until we change this condition into something that's true, no one is going to see this code. So I effectively have a developer sandbox the way that I would have by doing development on my machine today. And then the condition can be anything. It can be, is the user in beta? Is the username my username? Because I'm just testing it for me. Has a header been passed that says that this is the QA department doing their testing on it? All of that can be done by feature flags. They're extremely powerful. And the environments is the interesting thing, because you get environments by using these feature flags. So you can have a QA environment. You can have an environment that's set up for someone to do code reviews, but instead of having to spin up this entire clone of the infrastructure, all you have is an if statement that those people can't see it. So it's incredibly powerful and at the same time quite simple. And we use this for basically everything. And so when you think about this CI/CD pipeline and the steps that are actually involved in here, well, this Kubernetes thing, that's not important. The merging to master branch, that's not really important. The deploying to production, not really important. A lot of this testing stuff gets merged in. We've removed all of this. All we have is as close as possible to the essential complexity, making the change, running integration tests, doing code review. Not convinced those are essential complexity, but I can't figure out how to remove them yet. And then the feature flags and enabling it for users. Thank you. And each of these steps are just like one quick command in the editor, so they're not even long steps. And many of them are optional. So that's the basis of our deploy list tooling. Feature flags are sort of do vast majority of things. But I want to talk about where we're going and some of this stuff we do and some of it we don't do yet. So testing, version control, and code reviews obviously fit in with that feature flag. So when you've got a feature flag, we're going to use the traces that we already saved to create tests for you automatically. And then when you switch from one version to another version, you want to check that those tests still work. And that will happen in the background automatically. Version control are going to be the same as feature flags. We're reducing the concepts of version control and feature flags into the same concept. There's no reason they have to be two things. And then feature flags, once you've got a feature flag open, this is where you're going to do your code reviews. So you're going to have a fairly normal cycle of development that you're used to, except that we've cut down the extraneous stuff that you don't need. Some of the interesting stuff that we're doing soon, versioning is one of the most important things. I said earlier that it's important that you don't have the code changed out from under you. So if you've got all this code that works, you don't want to make a change to a function and suddenly not know what no longer works. And when you think about how we do deploys today, we take a whole package of code and we ship it all at once. And ostensibly, it should only be the feature that we change. But if you change a function, it's really hard to tell today what else you've changed apart from this one feature that you were intending to actually change. And this is particularly bad for packages, where we're using packages from NPM or something. We could upgrade one package, and then that package could change a transitive dependency, which affects another dependency. And you have no way of knowing whether you've done that. It's really, really difficult. And so versioning is our solution to this. Everything in Dark is going to be versioned. So functions are going to be versioned, types are going to be versioned, databases, we've done some versioning, languages, and the Dark language itself is going to be versioned. And what I mean by that is that if you want to make a change to a function, you're not actually going to make a change to that function. You're going to make a new version of the function, and maybe you're just going to copy the old version and then make a change to it. And the old version never changes. So that means any users of the old version know that their thing is not going to change out from under them. If you want to make a transition across your entire code base, you have to go through each one of them and use feature flags to make that transition over. And that transition means it's safe, and obviously we'll build in tooling to make that fast for things that you feel confident about. And the way we use this today, we support this in our standard libraries. So every function in our standard library is versioned, and as we've developed our language, we've made a bunch of changes to them. So if you wanted to access something in a hash table in Dark, we changed the signature at some point, and our users who use the old version of the function still use the old version of the function. Right? No reason to make them change. Maybe they have changed it. We did deprecate it, and because we deprecated it, new users who came after that have actually never been aware that there was an old function, except maybe for the presence of the v1 in the editor. So we're doing the same thing for types. If we make changes to the Dark language, we will version those so that your old handlers can use the old version, and your new handlers and your new code will use the new version. And then the other thing is data store migrations. So again, versioning is our solution there. Your data store is of a particular shape, and that's going to be the old version. And then your new shape, your new schema is the new version. And you create rollback and roll forward functions to transition between them. So you can continue accessing old data with the new shape, but also your handlers which used to access that database and are relying on that old shape can access the new data that's saved in the new shape by a rollback function. And as you transition from the old shape to the new shape, again, feature flags are your tool for safely changing one handler at a time to make sure that you're not breaking anything. So there's a lot of upsides from integrating all this stuff. And there are also a bunch of downsides. And the upsides all come from the fact that we have this integrated editor, language, and infrastructure. And the major downsides also come from this, the fact that our editor and our language, and most importantly, our infrastructure is integrated. And the real problem that I'm talking about is lock-in. People are going to be locked into the Dark platform. And that's actually not a thing that we're particularly happy about. Because people, I'm sure you know this, when you're a young technology company, any risk that is created by your company, such as lock-in, is a deterrent to people actually trying out your new technology and seeing how cool it is. So we spent a bunch of time thinking about lock-in. We want people to use Dark because Dark is cool and because it solves their problems. And we also want them to be able to move off Dark if we're not solving their problems. We want Dark to succeed on its merits. And there's two situations that people worry about. The main one is what happens if Dark dies. All right, what happens if the funding climate changes and you know, the economy crashes, that sort of thing. And it's possible that someday we might have to shut the doors. Now, I don't think that's going to happen, but need to make sure that our customers are taken care of in the contingency that it happens. So what we're going to do there is, if Dark shuts down, we're going to open source Dark. We're also going to make sure that our customers, that we keep it going long enough that our customers can transition off it. And we're also looking at setting up some sort of legal basis for this. So a contract of some sort to make sure that it's not just our word and goodwill that is going to enable us to open source it if we have to shut down, but rather some sort of cast iron legal contract of some kind. And that's the sort of thing that we'll work on before we go to general release. Right now, we just know that we want to do it, but we don't know what that looks like. So the second situation is what happens if Dark survives. What happens if we're doing great, but you need to move off for some reason. Perhaps you want to bring the thing you built on-prem. Perhaps Dark is too expensive for you, and you need to be cheaper. We certainly wouldn't be the first people to jack up the price. This happened with App Engine. This happened with Lambda. People weren't happy about that. So our major solution to this is, our first solution to this is that we want Dark to be cheap. We want Dark to have a utility pricing. We want it to not be this take all the value that you're getting and be a little bit cheaper than that. We're aiming at within 2x the price of if you had written it yourself in like Node or something and we're running it on AWS. And our plan is to get really good at compiling Dark programs so that we make that up in margin on that later. The other thing that we're planning to do is to make sure that you can migrate off Dark. if you need to. So your data is already available to be migrated off Dark. You can just create an API in front of a database and just pull all that data if you want. You're likely to want a slow solution, so you're likely to want a feature flag where you can pull slowly, so all the controls will be there. And then if you need to get the code off Dark, right now we allow you print your code, which isn't really useful since there's nothing that can interpret that. We're going to do two things. So one, we're going to allow you to compile binaries off Dark, so something that you could run on another server with possibly really ugly code. And then, of course, allow you to compile pretty code that maybe doesn't have the exact same semantics, but is like roughly what you were looking for. And you can do those ports a little bit at a time. So it's super important for us that you can move off it. The other thing that's really important about Dark is sustainability. We want Dark to be sustainable. We want Dark to be a sustainable company, and we want our users to always be certain that Dark is going to be around for them. And that means more than just like, is Dark going to shut down or is Dark going to be expensive? It's really about the ecosystem. And so we spent a lot of time thinking about how can we make sure that Dark is a sustainable product. And when you look at open source today, which is the primary way that people go for sustainability, there have been significant changes over the last couple of years that make it difficult to be sure that open source products are sustainable. So the first one of them is that many open source projects are underfunded and underpaid. And you can see things like the OpenSSL saga from 2014, where there was just one maintainer for this crucial piece of infrastructure. Or you can look at what's happening in the NPM world at the moment, talking about like the funding library. And we still have not solved how to pay creators for the value that all of our companies are built on. And that's going to be an important conversation, and it's one that's not yet solved. The other situation that we're really seeing in the last couple of years is that the companies that are built around open source, and this is Elastic, MongoDB, Redis Labs, are switching their licensing to not open source licenses because Amazon and the other cloud vendors are making versions of their product that cut out the revenue stream that those companies were using to invest in their products and to invest in their ecosystem. And so when we look at our options for Dark, and we look at how well-funded potential competitors are, at how well-funded these cloud giants are in particular, it seems to us that the best way to have a sustainable ecosystem is for Dark to be hosted. And that way, the people who work on Dark are paid, and we're paid by our users. Our users pay for infrastructure, and if you use Dark a little bit, you'll pay maybe nothing, maybe a little bit. And if you use Dark a lot, you'll pay a lot, and that will go back into developing the Dark ecosystem. We're looking at seeing how we can fund people who build the important packages as well as just the people who work on Dark, and that revenue stream is for that. And we know that not everyone is going to be happy with this. We know that some people are not going to use Dark because they can't run it themselves. Maybe they've legal restrictions that prevent them from running it, or from using Dark if they can't run it themselves. And we're okay with that, because what we're trying to do is this new holistic thing that has this very integrated thing. And we believe that there's many options if you don't want something integrated. There's many languages out there, there's many infrastructure options. But having the really cool stuff that we're doing with Dark requires it to be integrated. So speaking of the cool stuff that we do with Dark, there's a couple of things that I'm going to talk about right before we get to the end about what we do with this holistic integrated tooling. So end-to-end types is one that we do, and what I mean by that is there's no impedance mismatch between our database and our language. The types that are in the database are the same types that are in the language in the runtime in memory. There's no ORM in between them. There's no abstraction leak across from that. We're also building an infrastructure compiler. So today, Dark is a fleet of interpreters running in the cloud. and it's multi-tenant system with a multi-tenant database. But that's not the dream for Dark. The dream is that we're looking at your application, and we're looking at your code, at your data, and at your traffic, and putting those all together to figure out what is the ideal distributed system, and preferably single-tenant distributed system, to run your infrastructure. And that's what the vision for Dark is. I'm going to skip right past the error rail and go straight to live values. So live values, you saw this from the demo. And these things are one of the most amazing things that we get from coding in Dark. And a live value is that you're able to go to any point of your program and click on a variable, on a function, on a field, and see what value that was in a recent execution. And you can kind of think of it as Dark's debugger. And when you think about debugging, there's sort of two camps. There's the people who believe in using this heavyweight debugger that allows you to step through the program. And then there's the people who believe that all you need are a couple of judiciously placed print statements to allow you see just the right thing at the right time. I feel those people fail to mention that it takes about 20 years to develop a really good intuition around that. But Dark has the best of both worlds. You can see any value at any point. You're not overwhelmed with logs. You don't need to load a debugger, or you don't need to insert the print statements. You can do this debugging completely post hoc for any request that's been made to your application. You can just click on any variable and see its value. And that's a significantly more powerful debugger than anything. And it has also taken out any complexity of inserting print statements, learning to use a debugger, etc. And it also makes it really, really easy for people to understand programs. So users sometimes ask us what's wrong with their program. And I can open any code base in Dark that I've been sent to, look at some things, and learn really, really quickly how things work, because I can click on any variable, and if I see something that's called like a user, I can tell immediately, is it a username, is it a user's email, is it a user ID, is it a user structure, is it the JSON for a user, anything like that I can immediately tell by looking at an actual value that ran through the program recently. The other thing about this is that it makes it easy to learn. We've had people who are using Dark who have 2 years experience, 5 years experience, 10 years experience. Some of them have experience with functional languages. We even tried it with people who have never programmed before. And these live values, because they tell everyone what the result of their computation is, it's no longer hard to program. It really reduces just the programming complexity of software. So the final thing I'm going to show you is how we organize code. So the way that we organize code today is we use files and directories. And the reason that we use files and directories is those were kind of what we had. All right, this is how our operating systems work, and this is where we put text and data. But there's no real reason apart from that. There's no actual value to this files and directory system. If I'm looking at my code base, it's very hard to tell what the most important file in that code base is. Which on our user journey, what files are involved, what code is involved, and which ones of them are the most important. If I'm looking in a directory, I can't tell which of the files in this have the code that have the highest latency or the highest cost. And with Dark, we're trying to rethink how we actually architect programs or how we structure programs so that people can actually see this information. And when you think about how you actually think about programs, if you start at a new team or a new company, and the senior engineer takes you to the whiteboard to explain to you how your application works, what is it that they draw? They draw an architecture diagram, and they explain to you the architecture of your application, how it groups, the connections between the various things, and that's what we intended to look like in Dark as well. This is a mock-up. We've started some work on this, but we're not that far along. And what we're showing you here is we show you the actual structure of your program. We show you the traffic and the data flow between various things. We can use things like size and color to show you what's more important, what has more traffic coming through it, and then we can overlay it with things like stats, with things like the latency, and even just how much it costs to run this particular component, which is a thing that people really struggle with today. So there's more stuff to Dark that we're coming in the future, things like how we handle accessibility, package manager, of course, pricing. And it's not done, but we really feel that we're onto something. We feel that we've solved a bunch of problems around complexity, in particular around the infrastructure complexity and around the deployment complexity. And to a certain extent, for ourselves, we've changed how we write code. When we code in Dark, we have a materially better experience than when we're coding not in Dark. So today, Dark supports backends for web apps written in React and Vue and all that sort of thing. For mobile apps written in Swift, Android, React Native, whatever you like. And people also use it for building internal tools in their company and for building new microservices to existing microservice-based architectures. So if you've got something which just speaks HTTP, Dark is a very good thing for speaking HTTP to it. All right, we're really excited to show you everything that we're launching, and I want to thank you for your support. All right, so it's been an hour and 40, so if you want to stand up and leave, no offense. But I'll take questions from anyone who's interested in asking any.
How did you think about the definition of this alpha product to be shipped to your first set of users?
Should I repeat?
Yeah,
All right.
great.
So how did we think about the definition of what done was, of what is going to be the alpha and now the beta? Basically, we got our first users in when Dark was basically unusable. And we knew that Dark was unusable, and we didn't know what the right thing was to do. So we put an ad on the internet, and it did well on Hacker News, where we offered to pay people $3,000 a month to come and build their product in Dark. And we had 2 takers on this. And they came into our office and they built their product in Dark. And every couple of days it would be like, this is broken and I actually can't work on this anymore, and we would go and fix all the things. And some of them took a moment and some of them took a week or two to fix. And we eventually got it to the point where they didn't have to ask us for anything anymore. And that's probably where the alpha started. And then we just kept doing that. We kept bringing customers in. The second one we also paid. They have an app called usealtitude.com. It's a flight deals SaaS. And when we just added more and more users until the point that that we felt very confident that users onboarded without having us to do anything. One of the major changes that is coming now is the editor, which I showed you the demo of the new editor. And that became because we weren't confident that our old editor, like that was the number one problem that people were having, was that our old editor didn't work that well. So with the new editor, we felt that users are now able to onboard fairly easily without our help. They're still making requests to us. We're still fixing things and building things, and will continue to be. But it's no longer such a massive burden anymore, and that's kind of what we're calling the beta.
Over here.
Oh, sorry.
I had a little bit about just a philosophical question about your point about accidental complexity. Mm-hmm. So a lot of times things that seem like accidental complexity, as you build something out, turn out to be essential complexity. Mm-hmm. And so the statement that a lot of things are accidental complexities, so we can just make them go away because it works right now, is kind of oversimplifying that sort of reality. So for example, databases, you might think you don't need how to have to shard your database early on, but then it turns out that that's an essential part of the architecture of your system. So I was just wondering if you wanted to talk a little bit about that, because there seems to be a tension between discarding accidental complexity and the proven validity of abstraction piercing, because you actually have abstractions, but you have to know what's below it.
So the question, let me repeat this and make sure that I got it right. How can we tell what is essential complexity and what is accidental complexity? Because often what people think of as accidental complexity is, once you really dig into it and discover the problems that caused that accidental complexity, we discover that it's actually essential. Okay, so a bunch of different ways. So one is that we know a lot about the problem domains that we're tackling. and you'll notice that there's many more problem domains that we could be tackling that we aren't. So, for example, we're not tackling front-end complexity because we don't feel confident that we have any solutions to that front-end complexity that's happening today. Even though it's super obvious that it's complex, we don't know what's accidental and what's essential. With infrastructure, a lot of that complexity we are taking ownership of. So we are running the infrastructure for you. So when you need to shard something, that will be us realizing that we need to shard something, and that will be us figuring out how it is that we are going to shard that. And it may be that we need to change our product to do that. In fact, it is incredibly likely that we're going to have to change our product in various ways as we start to get experience with complexity which we know exists and hasn't yet made it hasn't yet hit the edges of our product. So yeah, I mean, basically the answer is iterate, and we feel confident that the class of complexities that Dark is built around, that we can solve them, and a lot of them we're putting into this like mythical infrastructure compiler that will come later. And part of the reason is that we know that humans can solve all of this. So we believe that if we hire those humans, that we can put it into a compiler and sort of figure out the abstraction, so long as we have all the data. And it's unclear to us exactly how far this is going to go, but it's possible that for possibly once you hit Twitter scale or something like that Dark is no longer a suitable product. Our expectation is that Dark today should have no problem for companies with sort of 50,000 users. And beyond that, we'll see whether Dark is something which becomes the tool for absolutely everything, or whether it becomes the tool that sort of maxes out at some size.
It's whose job is it to handle those problems? And then one strategy is open source, because everyone gets a chance to look at that complexity, and one strategy is hosted. And so this is really sort of saying that this is pursuing the hosted path to deal with that, because you're owning those problems.
Yeah, exactly. We're owning those problems, and because we're hosting it, we have all this data that we believe we'll be able to use to solve some of those problems.
I guess my question is about failure debugging, which is stuff I'm thinking about a lot now. But a lot of some infrastructure today, observability, metrics, logs, events, these sorts of things are in support of people who are building complex systems and then operating them. And then, like your tail latency might spike, you might not have the right index on your database, these sorts of things. And so I guess it's maybe a bit of a fall-on or a different perspective. So obviously it's nice to be able, when you can, to push that off to an infrastructure vendor. But if anyone like me has had failures where you've sat and waited on an AWS support ticket, right? Like it can be nice to have some degree of in-house expertise. So I guess like, how do you reason about that? Like, do you have public postmortems that you put, or like, what have you learned from failure maybe, or are you thinking about learning from failure, not of these early high-touch customers where you can go and spend a week fixing their problem, but when you have hundreds of thousands of customers on Dark whose businesses, they want to have a faster iterative loop to fix when something goes wrong and maybe you're busy.
So I mean, the answer to that is that we sort of going back to that, don't invent anything new. So the public postmortem about certainly we're doing private postmortems today. When we have any downtime, we send customers that information, maybe a box of chocolates as well. So we're going to do the exact same things that people do today. We're going to be having ops teams. We're going to be doing a lot of monitoring ourselves. We're going to be pushing some of that data to customers, the kind of data that they need. And really, really the answer to a lot of these questions is just like, what do we do today? We're going to take the best practices of today, which we have a bunch of experience with, and adapting them to the Dark world. And not everything that we do today is something that an early version of Dark is going to be able to solve. And we're going to be super transparent with customers about what it is that Dark can really do now and what it is that Dark can do later and that kind of thing.
So I guess you've spoken a lot about like the perks and like the complexity that is being removed. But in your personal experience and your customers' experience, what are some limitations and say like unnecessary complexities that they have faced, like while using Dark?
So the main complexity that people have faced using Dark is where Dark didn't work. So bugs from being early. Had a customer today who was having problems with cut and paste, and those are real. And we've discovered that the vast majority of problems are in the editor. That the infrastructure hasn't really been a problem for anyone, mostly because we've massively over provisioned it, and that's kind of a good solution for the early days. But the kind of problems that customers have had have largely been what parts of the code bases or what parts of the product have we not built out yet. So for example, the database migrations are a thing that customers now have to do manually. So they're manually making a new database, they're manually writing the code to like copy it over and manually like syncing it up. And so like the tooling will solve that, but we have to get to it. So it's I would say the majority of the essential complexity today is stuff that we're causing. Our expectation is that of the other essential complexity, the stuff that we've seen most of are things that we actually just can't solve. So say, for example, a customer is trying to load all of the data from the database and do computation on it in a short amount of time, and times out after 30 seconds. That's the sort of thing where we can't solve the exact specification of the problem that they went with, but we can work on stuff like denormalizing, figuring out the exact query that they want to do, and so we can solve a lot of those with building more products into the features and just more features into the product and figuring out like what is a better specification of the problem that they're having. Can we make it so that there's a blessed way of doing this that they're actually able to solve the problem? All right, thank you. I'll be around. So please ask me the rest of your questions.